So, good evening, ladies and gentlemen. Gianluca Masi speaking from Rome on the behalf of the Virtual Telescope project. It is a great privilege for me to be here, just going to share with you live in real time, as it is typical with the Virtual Telescope project, the Comet C/2017 K2 Panstarrs, reaching right now the minimum distance from the Earth. Before we start telling a bit more about this comet and above all sharing real-time images of this very nice, wonderful, hazy world, I really want to thank the technological partners of the Virtual Telescope project, and they are Unitron Italia Instruments, Software Bisq, C-Web and Telescope Live. I also want to thank our supporters, Playing with Instruments and Other Planetarium, and all of you who from time to time decide to contribute to the Virtual Telescope project with donations, making possible for us to keep alive. Always keep in mind, we never ask for money to you to join our live feed, but of course there are bills to be paid, and if we are still around after 16 years, having now a truly legendary international reputation, it is thanks to the people who decided to support us, making possible for us, as I say, to pay bills and cover maintenance of our advanced robotic facility. Let's say we are here just to track this comet. You have been hearing a lot of things about it, very likely, so I want to ask our robotic system to start taking images just to be sure that we will have fun and that we will see something together, my friends. So I'm just checking that the system is up and running, the robotic telescope, making possible for everyone here just to spot this nice object. So let me start sharing the interface I use to control the robotic telescope, my friends. Here it is. If you are used to the Virtual Telescope project, you know what we usually do. That is the system, that is the computer physically connected to our robotic telescope. I am in Rome. The telescope is about 100 kilometers south of Rome, just to be under much better skies than those available in a big city like Rome. And I am connected from here, so this is a truly robotic telescope, and you are somewhere on this beautiful planet we call planet Earth. And this is a clear demonstration about how beautiful technology could be, just sharing something happening right there in the sky via the technology. And this is just the software controlling our robotic mount. Here you can see stars after all. Let me see if I can also share with you. Okay. Look, this is a portion of the night sky just above the observatory. And of course, here, when you see the red crosshair, it is where the comet is sitting right now. You can see there are many stars all around and constellations, and these days and these nights, Comet Panstarrs is just crossing the region of the sky where the Ophiuchus constellation is. And just to give you an idea of the position of the comets in the sky, just to give you a better idea, here you have the Scorpius. Let me see if I can add right away a few star names, just making possible for you perhaps to have even more confidence with the sky we are observing. So here you have Antares, the brightest star of Scorpius, a very bright one, and the typical star Vega, typical summer star just overhead, at least from the observing site in central Italy. And the telescope is already pointing this comet, and I would like to start just taking the first image. Before I start, keep in mind, here you have the moon. We had the supermoon 24 hours ago, so the moon is still basically full and just spreading a lot of light out there, and this is clearly a very strong interference. So the vision we will have tonight, it is far from being the best vision possible, but still tonight this comet is at the minimum distance from the Earth, and of course, no matter the moon, we wanted to be here having a look. So let me take a very first and just a preliminary image. I will ask my system, my telescope, and after all to the camera, the very sensitive camera installed on the telescope, to take a first image, just a first and quick image, just to have a look. And having that image, I will start telling you a bit more about these interesting comets, my friends. Image is coming. It is just a matter of seconds, because I simply asked to my imaging device to collect light from the comet for 15 seconds, and here we have. You can see, we clearly see the comets. We see many stars, those dotted lights, but of course here you have the comet. This is the central condensation of the comet, and clearly a hint of its dusty tail. As I said, keep in mind there is plenty of lunar light out there, and this is of course giving such a lot of interference. I'm just trying to make the image perhaps a bit more natural, just adjusting a few things. So that is, my friends, the long-awaited Comet K2 Panstarrs, to use the short name, at least in this case. And I want to say a few things about it. Comet C/2017 K2 Panstarrs, as perhaps you have read around, was discovered a few years ago on 21 of May 2017, hence the name, the year in its name. And it has been found by the Panstarrs survey at the Hawaiian Islands, just looking up every clear night, looking for asteroids, mainly near-Earth objects, of course. And when it was initially spotted, this comet really surprised astronomers, because on the discovery night, this one was sitting somewhere between the orbits of Saturn and Uranus, at 2.4 billions of kilometers from the Sun. Trust me, friends, that is a very huge distance. And later on, we also found images dating back to 2013, something we call recovery. When you look for images of an object you discovered today, and you find that those objects was already observed in the past but went unnoticed, and we call that circumstance just recovery. Okay, so this one was discovered in May 2015, and after we have found images of this comet dating back to 2013, but nobody noticed the comet there. Keep in mind, I say this one was, when discovered, was at 2.4 billions of kilometers. It is a lot of kilometers. It is a very huge distance, and having a comet active at this very large distance is honestly uncommon. Perhaps some of you remember Comet Hale-Bopp, and Comet Hale-Bopp was comparable to this, just to make clear that if you really want to find a similar comet that active, similar activity at such a large distance from the Sun, you have to call for Comet Hale-Bopp. I mean, a now legendary comet, okay, and which was discovered, by the way, in 1995 by Alan Hale and Thomas Bopp. And later we also discovered Comet Bernardinelli-Bernstein, which is even more intriguing, but this happened later. So when this comet K2 Panstarrs, was discovered, it really showed to be honestly a truly outstanding object, and of course it was asked to be used for the Hubble Space Telescope, and investigation made done with the Hubble Space Telescope suggested that the icy nucleus of the comet K2 Panstarrs was about 20 kilometers large, so it is huge. More or less, it is as big as the Halley, Comet Halley nucleus, just to give you an idea. And the Halley nucleus has been visited in 1986 by the Giotto spacecraft, by the way. And if you look for images of the Halley nucleus image, you will find some very interesting ones. The first images with the detail ever obtained with the comet nucleus. And there were also studies just suggesting that the nucleus of this comet was larger, 80 kilometers more or less. Let me take images back to back so that at least we can see even this comet in motion. Keep in mind, look here, you see the comet here, and on the left you see a bright star. Now I'm taking a new image several minutes later, and the image we show the comet motion. Look how the position of the stars relatively to the comet will change now that the image will be downloaded. Look, let's see. Here it is. This is happening because, of course, the comet is in motion. And by the way, if you don't mind, I would like to do this just to be sure that later. Okay. Let me take a number of these, even a shorter time. Okay. I want to start this sequence before going further with my description, just making sure that you have something to look at and changing, slowly changing, evolving, giving you the idea of a real-time experience. Okay, having used a shorter time, I need to adjust here a few things. Just going there. Okay, sorry. As you see, as always with the virtual telescope project, we share with you everything. For a while, you should feel like a real astronomer just working at the telescope, doing something. Here it is. Every 10 seconds and every 10 and a few more seconds, a new image is uploaded, and the image after image you should be able to see this comet in motion. So back to a quick description. So as I say, this one was found in 2017 while it was very far from the sun, 2.4 billion kilometers. Despite the huge distance, it was very active, something very unusual. Before this comet, only Comet L-Bob, discovered in 1995, was active at a very large distance from the sun. And now we also know Comet Bernardinelli Bernstein, even larger than this and active at even larger distance. Anyway, we asked the Hubble Space Telescope to have a look, and the observation suggested this one, Comet K2 Panstarrs, to have a large nucleus, more or less 20 kilometers, not very different from the size of the Comet Halley nucleus, okay? Even if some estimates suggested even larger diameters, around 80 kilometers. And while we are, of course, speaking, this comet is, as I say, just at its minimum distance from the Earth. But while it is the minimum distance, so we will never have the comet closer than tonight during this passage, this is still a huge distance, because right now, while at the minimum distance, Comet K2 Panstarrs is as far as 270 million kilometers. So it is a lot. Keep in mind, the average distance of the Earth from the Sun is 150. So this is almost twice, 1.9 more or less, the distance between the Sun and the Earth. So while at its closest from the Earth, this comet is honestly very, very far away, and it is visible from both the hemispheres because it is sitting not far from the celestial equator, so it is very well placed to be observed from both the northern and the southern hemisphere. So it is, I would say, a democratic comet, making happy everyone on this beautiful planet. And if you have a binocular, it is now the time for you to take it, okay, and try to locate this comet, because while huge, while very active, this comet is too much distant from us to be visible by naked eye. It is such a pity. Otherwise, if this comet was just in the condition to come closer, it could be, honestly, it could really be a huge show. But unfortunately, as I said, it will stay so far away, almost twice the distance of the sun. But despite this, you can really see this comet with even a small binocular or a small telescope, by the way, as I said, in the Fucus constellation. And we are happy to bring to you in real time this comet tonight, right now. Comet K2 Panstarrs is showing in real time to you via the Virtual Telescope project, my friends. And I'm honestly hoping that this is just bringing to you the beauty of the experience and the excitement of the real-time live observation. Okay? Just at the minimum distance. This is why we scheduled this experience now. Unfortunately, as I said, it is not visible by naked eye, but even modest equipments like small binocular or telescope will make possible for you to see this one, provided you know where to look, and you can find on the net many detailed images, star maps, sorry, and we are going to add a star map tomorrow on the Virtual Telescope Project Facebook page as well. So if you have even modest equipment, it is right now the very moment for you to go out there and look for this comet. Keep in mind, as I said, these very nights we have basically the full moon there, but in a few days, while the moon will move in the second part of the night, the interference by its light will be smaller and smaller, and we will be able to see the comet better and better. So I would suggest you to wait for 2-3 nights and observe early in the evening, as soon as the sky is dark enough and before the moon rises, just to keep its light away from your side. I would suggest you to try and have fun, and it will be visible through small telescopes for several months to come, so really no need for you to rush. I also want to add that the relative speed of this comet relative to the Earth is about 35 kilometers per second, and this is its overall speed. But if you consider the speed at which the comet is approaching, it was approaching, okay, until it reached now the minimum distance. Now, so the approaching speed is 0, and then it will be positive as it is now leaving us. But the overall speed relative to the Earth is about 35 kilometers per second, and as I say, this one right now is at 270 million kilometers from us, almost twice, 1.9 times the distance from the sun of the Earth. So quite a lot, my friends. And as I said, this is honestly a unique comet because it has been found very active despite the large distance from the sun, 2.4 billions of kilometers, truly a lot. And having the opportunity to see a comet with a small equipment, and even I would say a top comet like this, it's not happening very often. So I would really suggest you to, if you have a small telescope to try, and at least we were happy to share with you the experience. And the comet, while the comet is reaching tonight the minimum distance from the Earth, it will reach the perihelion, that is the minimum distance from the Sun, next December 19, not very far from Christmas, and at that time it should be even a bit more brighter, but we will see. Comets are out there just ready to perform in a very different way than expectations. Sometimes they perform much better than expectation, sometimes they perform much worse. So let's hope this one will perform much better, but we can only hope, unfortunately. And you can see image after image how this one is moving, because the position of the condensation of the comet is just moving respect to the stars you see all around. Here it is, for example, just enlarge it a bit. How beautiful it is to see this motion. You can see that stars are showing very short trail because this one is moving, and image after image, of course, we see the motion, my friends. We are using the main robotic telescope available at the Virtual Telescope project, by the way, a 17 inches large instrument. Truly nice and amazing instrument, as I said. Now let me see if I can I would like to wait for, okay, we collected a few images, and now I would like to take a completely different image, much longer exposure, 2 minutes, significantly better resolution. So with this new set of parameters here, we should see again a better hint of detail of the tail and clear evidence of the motion. In this image you still have a hint, and look here, even a satellite. Just playing the very same image. I really like all these, my friends. Sorry. How many things can be done once you have an image. And a computer. This is the beauty of digital imaging, not only in real life but also in astronomy, my friends. This is the same image. I'm just adjusting contrast, brightness in a very simple way, and trust me, there are much more performing techniques than this. But of course, the idea here is not to make a tutorial of image processing, Comet imaging processing, but just to share the experience live. And we are 15 seconds left, plus a bit more. And of course we are now facing this white screen because the image we were spotting earlier was taken in a handful of seconds, now 2 minutes, so much more light collected, much brightest image. And now I just click to ask the system to just set some automatic parameters. Look, really nice. How beautiful Comet Panstarrs is, shared in real time via the virtual telescope project while it is at its closest. About 270 million kilometers, my friends. I'm just trying to adjust contrast and brightness. As I said, we have a lot of moonlight out there, and of course this is creating interference. But now look at the stars, because next image should show clear evidence of the motion. And this is something I always love to share with you. Just a few more seconds. Look. Now downloading. Star should move on the upper right slowly. Just want to check one thing, if you don't mind. Here we are with our icy world, this dirty snowball, Comet C 2017 K2 Panstarrs, my friends. I really like comets in general, and you know, comets very likely had a very important role bringing on our planet water and complex molecules useful for life. And this is why I really love looking at these amazing objects every time, my friends, every time. Having fun together. Hope so. Happy to bring this to you in real time. As you can see, new images coming shortly. I would like to take a few more images, and I want to have all the people connected, noting how the comet is moving, and every new image you see the stars gently moving to the upper right corner, because the comet is moving in the opposite direction. And I asked our advanced telescope just to track the comet. As we see, perhaps This choice, even if a bit noisy because of the strong lunar contamination, the moonlight is offering to you a nice compromise, showing the nucleus, the bright nucleus very well, but also the fainter outer region of this comet. Very nice to me. Comet Panstarrs C 2017 K2 Panstarrs live, brought to you for free via the Virtual Telescope project. And hope you are having fun with us. I plan to capture a bit more images while live, just waiting for the fifth image. Having this visualization, just optimizing, the nucleus, the brightest part of the comet, and the faint coma all around, and clearly a hint of the tail on the right, the dusty tail. As I said, while this comet is right now at its closest, but still 270 million kilometers, unfortunately there is such a bright moon there, making very hard to spot it. But if you will wait for a few days, you will see the same comet, the same brightness, under a much better skies. But we really wanted to be here tonight, just for the record, as tonight this interesting, very large and very active comet is at the minimum distance from our own planet, the Earth. And once I will have this image, I will ask the system, of course, to take a long exposure image, which will be the last one, 4 minutes integration, twice the time we are using, to hopefully show you much better the apparent motion of this icy world across the stars. But keep in mind, in 15, a bit more seconds, the new image is coming, and look how the nucleus will change position, for example, once compared to the bright star you have up there. Now coming, look, the new updates, how the nucleus is slowly moving. We are tracking the comet, and now let me ask the system to take 4 minutes long exposure frames. Very nice to be here together, ideally looking up. This comet coming from the Oort cloud. This is the last image. I really like bringing to you the experience of the night sky in real time, something the virtual telescope have been doing for a lot of time. how fascinating these icy words are. Waiting for the last few minutes, and hopefully you will see the motion much better. And by the way, I want to thank all the media worldwide which featured our live feed, making possible to people around the globe like you to jump and have this experience together. I'm happy to see, well, this month has been quite intense for us, sharing many things, recently asteroids, yesterday the supermoon, and now Comet. So this very intense activity made possible for you together with us to see how many things are up there. Comets, asteroids, our natural satellite, the moon. But there are even galaxies, nebulae, clusters, and so on. And we also had fun and a lot of excitement with the James Webb Space Telescope. By the way, we tracked the James Webb Space Telescope for several weeks. Soon after it was launched in space, the last month, early this year, and we also shared it in real time. And it was a lot of fun seeing that very small dot of light moving across the starry sky, and that was James Webb, of course. About 30 seconds to go with our final image, my friends. As I said, if you think this project and this experience is worth your support, you are invited to join our website virtualtelescope.eu, and if you want to support us, you can donate, you can just contribute, keeping this project alive. And here it is, my friends. As you can see, with a double exposure, we are just twice the length of the stars, my friends. That said, with this very final image, we are going to close this live feed, bringing to the world Comet C/2017 K2 Panstarrs at the minimum distance from the Earth. Once again, the Virtual Telescope project made possible for everyone on planet Earth to join the experience, have a look personally from the comfort of your home for free. And we are very proud of this, and if you really think our mission is important, please consider the possibility for you to support us, even with a very small donation, visiting our website www.virtualtelescope.eu, and from there you will easily see how to donate and support us. We will never ask for money for having a look with us to the sky, but of course, as you can see, this advanced technology is not free. We have to cover maintenance, to pay bills, electricity, internet, and so on. So please consider the opportunity to support us if you think that our mission is worth your trust and support. That said, my friends, I'm just going to close this one right now. Hope you had fun together. Please keep looking up and register on the Virtual Telescope Project Facebook page to be sure you will know as soon as possible, right away, the next opportunity we will offer you to look up and surf the cosmic space out there. Gianluca Masi, Virtual Telescope Project, www.virtualtelescope.eu. And if you like what we do, please go there, virtualtelescope.eu, and consider supporting us by donation. Thank you very much. Keep looking up, and thank you for your time and for looking out there with us.